But yeah, let's go ahead and get started. So first thing is this one's going to be a little bit different than other like sometimes I've done webinars that just introduce you to positive physics. This one's going to be a little bit different. So thank you so much for coming. It's not just for positive physics users. So if you, I know some of you use positive physics, great. Some of these strategies are already baked into positive physics. Some of them will be new, but if you don't use positive physics, that's completely fine. I hope that you find this helpful as well. By the way, some of the things that we talk about, like I'll make some references to positive physics. Even if you don't use it, you are welcome to go in, screenshot it, and use it for free with your students. That is completely okay with me. And then also, please do ask questions anytime. Either unmute yourself and ask, or you can put them in the chat. I have the chat up. It's I like to be interrupted, so it's not just me talking for too long. Also, before I forget, I never send my $15 to Zoom, so it cuts us off at 40 minutes. If we're in the middle of something, just I don't think we'll be on here that long. But if we do get cut off, just click on the same link and it'll allow you to rejoin. Cool. So a little bit of background to start with is first, I taught for 13 years in public schools in Memphis in Title I public schools. And yeah, and a lot of these lessons come from a lot of trial and a lot of error with teaching my students there. So I taught a lot of students who came to me, they grade levels behind in math and reading. And Janice, yeah, I'll send a recording of this immediately after we're done. But yeah, thank you for asking questions at any time, and do keep your eyes on the road. Yeah, so a lot of my students came to me well below grade level, and I tried to teach exactly the same way that I'd been taught and how the textbook was teaching, which looked a lot like this. This is actually a screenshot from Khan Academy. And a lot of it, my first year and a half really were a disaster. I really, really struggled. And I actually found that I had a lot of like classroom management issues that derive from the fact that my students couldn't do the work that I was assigning them. And then instead of trying and like looking bad, they would do other things that I didn't want them to do. So when you take a look at this, if you try to put yourself and look at it through the eyes of a lower level student, this is a lot. So a lower level student might not even know what's going on here. I think we can all see that it's a box, supposed to be a box sliding down a ramp. But to a lower level student, there's just so much going on. I think that gets lost. So my first strategy, first an overview. We're gonna go over 7. I think in my email I said 5, but it turned into 7 strategies. And yeah, some of them will be general strategies, and then I have a couple strategies that are specific to teaching motion and to teaching circuits. So as I was saying, that image that we saw from Khan Academy, there's just a lot going on. So my first real tip would be to always, especially with lower level students, always try to use a real world example that they can relate to. And whenever possible, use a simple notation. So on this right here, even like F sub G with an arrow over the top just means the weight. So FG by itself would just be better, or I prefer using a W, but simple notation and real world examples. So another way to look at a problem like this, and if you use positive physics, you know it would look like this. So just already, it looks more doable if I'm a lower level student, but honestly, it's still a lot. So the big like game changer for me was when I recognized that instead of starting a unit and trying to teach a problem like this, which would maybe take 10 or 15 minutes to go over in class, when I would then give a similar problem to a student, they would have forgotten the first step of the problem. And they'd only seen each step one time. So they had very little chance of actually being able to do this after just going through 1 or 2 of these examples. So I started breaking the problems into bite-sized pieces called building blocks. So this is like what I would call an inclined forces unit. And if you use positive physics, you're familiar that we do this, we built it into the website already. But if not, what I'd highly recommend is like first, just breaking these down into the simple parts. So the first thing is just drawing free body diagrams. So before we get into all of the math, I like to give students lots and lots of practice with lots of situations where they're just drawing really good force diagrams. especially with something like this where they're drawing some of the forces at angles. Just isolating that skill before you even show them kind of what's coming next. And then following that, I like to have my students just practice trigonometry. So especially for a lower level student, trigonometry is intimidating enough as it is, but when it's combined within the rest of a problem, and they're only getting like one chance to practice it in a 10 or 15-minute long problem, it's just not enough. So I like to give my students 5 or 10 problems in a row where they're just practicing the trigonometry. So if we say there are kind of 4 parts to solving this triangle, so the 3 sides and the angle, giving them a variety of things, a variety of problems where 2 of those are given, but a different 2 given, then they can really master the trigonometry before they try to put that into, combine that with the other skills. And then probably this next skill was the biggest game changer for me. So a lot of times I'd have students, they do great, and then they would get stuck on either finding the net force or finding the missing force in a problem like this. So I started giving them questions where I'd already, the previous days we'd gone over how to do the trigonometry and how to draw the forces. So instead of spending more time reviewing that, I would just give them problems like this one on the left, where all they're doing is finding the net force and figuring out if the speed is increasing, decreasing, or constant. And they could do a ton of these in a row. So if each of these problems takes 30 seconds, they could get 20 at-bats at this in about 10 minutes to really understand how to find the net force in a situation like this. So I'd say that going back to that first problem that we were looking at, these are the 3 building blocks that I would teach before actually putting these together to solve a problem. And now once you do that, now a student knows the different pieces of this, and doing this and just adding this equation isn't so bad anymore. A couple other things on building blocks. So what I found was really, really cool was that when I was doing this with my students, especially when using positive physics, if I taught those first 3 skills individually, I would have students work ahead and start doing the complete problems before I even did those. So if they could master those 3 skills, then they could even just by themselves they would naturally start trying the complete problems and even getting them right without even going over them in class. The other thing I wanted to add is that I always really liked, at first I didn't do this, and then I realized instead of just thinking them as building blocks to get to this final thing and just assessing these final, what I call complete problems, I would, whenever you give a quiz or a test, I would actually assess these building blocks separately. And a couple reasons for that is, one, you can figure out like where your students are struggling. It's like maybe it's the trigonometry that's throwing them off. And then you can go back and reteach that. So it really gives you good data on where you might, on where your students might be struggling. But then maybe the bigger reason is I had some students, especially some students who had IEPs, that they probably weren't ever going to get to the stage where they could solve a problem like this. But they still enjoyed my class because they knew that, okay, I could get a problem like this completely right, or a problem like this completely right. And they could start to see that they had a chance to be successful, even if this ended up being too much for them. And then eventually they might surprise themselves and actually really be able to do that. But it gives a lot of students a lot of confidence to be able to get some things completely right. I think it's a lot for a student psychologically. It's also a lot better than just giving partial credit. If you really show like, okay, I completely mastered this skill. All right, so that is kind of my building blocks was the biggest one that really, really transformed my classroom. And again, if you have any questions, please do just feel free to unmute yourself. We have a fairly small group, or put questions in the chat, either way.
Hey, Jack.
Hey.
How you doing? So good to see you. I know you said you hate to talk, and so I'll just add to, I think it's great that you like to assess individually, because it's funny, like I don't teach really low level kids, right? Like I work at this really nice private school in Greenwich, Connecticut. But I can have low level kids, but they can all do trig and they can do stuff. And it's funny because they'll pound through and they'll get through the complete problems. But when I give them the tests, I give them all that conceptual stuff too. And sometimes they struggle with that, right? Like it's not all about just memorizing the math. And that's what I always try to like let them know in physics. Like it's not just, physics shouldn't just be a math class, right? And I'm a math teacher. That's like what I do by trade. And it's not, it shouldn't just be a math class. And I like to like get the conceptual part of it that you keep on there. Like I give them that on their unit tests. So I think it's great.
Gotcha. Yeah, that's really good to hear. And honestly, that's been one of the biggest surprises for me about positive physics is I thought it would mostly just be for lower level students, but and that's kind of specifically what this webinar is about. But yeah, I found that higher level students like really benefit from that approach as well. I think it's really helpful for high level students, and then but absolutely necessary for lower level students. Cool. So let me move on to number 3. So this one is specifically for lower level students. And that would be another real game changer in my class was giving students pre-manipulated equations. So I realized I had a lot of students in my class that they would, especially if they came to me directly from their math class, they'd feel like they just didn't have a chance to be successful. And then they were almost being punished twice for, like, first of all, they're struggling in math, and then they come to physics and they like don't have a chance to be successful. And I realized it was really, really frustrating for them. So I started giving them equations. And sometimes I would do this, like if I had a full class of lower level students, I'd give this to everybody. Or if I had just a few lower level students, I would give just them a sheet with these pre-manipulated equations. And then like, I think physics is worth learning, like not just to practice your math, but like I think it's its own thing that's valuable to learn. And so giving these students something like this, so they knew they didn't have to stress out about if they struggled with the algebra. They knew they had a chance to be successful. This is new, by the way, this year, is that on positive physics, and I'll put the link to this in the chat. Let me see if it'll, okay. We have an equation sheet with every equation that you could think of, both the original form and the manipulated form. If you do have higher level learners, you have the option of hiding the manipulations from them, so they just see the original form, or you can show them the manipulated form as well. I'm going to put this in the chat, and feel free to use that, whether you use positive physics or not. Yeah, so then let me find my PowerPoint.
Are those formulas always available to the students as well, or would that be something that we sort of enable or allow them to see?
Gotcha. So on positive physics this year, let me go ahead and show you. So right now, they do show up by default for everyone. So if you click back to reference, they're on there. I have it set where the manipulations aren't shown right now. But yeah, we also, if you've used positive physics before, that's not a great example. Let me go to this one. The videos now are kind of within the skill, so you don't have to do as much clicking around to find them. As a student, you can just click back there, and you can also click back to the reference sheet. Cool. All right. Yeah. So then another thing is, I think the hardest part, like especially for a lower level student, is just knowing how to start a problem. If you've watched the videos on positive physics, you'll kind of see that this is my style. But one thing I thought that really helped was my students was just starting every problem by just listing what you're going to need, like all the quantities that you're going to need. So on a motion problem, I'll talk a little bit about why I always do average velocity, but just listing initial velocity, final velocity, displacement, time, and acceleration. Just listing those 5 or 6 things every single time was a great way to start the problem. And then what's especially useful with motion is you can tell them for a one-dimensional motion problem, you have to have 3 given. Don't even look at your equations until you have 3 given before you, don't look at equations until you have 3. Paula, I know you wrote in the comments about using D instead of delta X. I'll talk a little bit about that in just a second. For a momentum problem, I start by just listing PMV. drawing the object before the collision, drawing the object after the collision, and then listing PMV underneath each object, just getting students in the habit of that, and then they start filling in their given from there. Similarly, it's a little bit different with a energy problem. I start by having students, okay, first just identify the type of energy you have at each time, and then underneath the type of energy, just list the things that you see in the equation. And I found that if students can set this up, they have a lot better chance to get started on the problem. And even if they don't finish it themselves, then in class, they end up asking me a lot better questions. Cool. And then, and again, yeah, jump in anytime if you have questions. All right, and then this one. Okay, I put an asterisk here to remind myself that this one, I think there is some disclaimer, so I'll hit those afterwards. But for my students, I like to teach my lower level students to do motion with the scalar equations. So I learned that you could solve almost 95% of kinematics questions you can solve with these 4 equations. And if you use scalar, you actually don't have to worry about your negative signs on this. So this is an option on physics. You can use normal vector mode, or you can use scalar mode. But if you're teaching a conceptual class or you're teaching lower level students, I found it really, really helpful to use one, like easier symbols like distance instead of displacement. And just using d instead of delta x, as well as if you always calculate the average speed, you don't have to use those longer equations that can throw students off. I also really like the conceptual idea of understanding that an object that travels with a constant speed of 8.15 meters per second travels just as far as an object that, if the speed increases from 0 to 16.3 like it does here, then the object travels just as far as it would have if it traveled with a constant speed of 8.15. I also like the conceptual part about students can easily check their answer by realizing that the average should be halfway between the initial and final. And again, if you just use these 4 equations, you can solve almost any kinematics problem, not worry about negatives, and not worry about long equations. The disclaimer here is, if a student is going on to take a course, like if you think your students can go on and take a college physics course, this can be confusing for them to switch notation later. So I think, just really be mindful of that when kind of deciding what equations to use. But I really had a lot of students that were really successful using these that really would have struggled with the normal kinematics equations. All right, and then my last one is a specific circuits teaching strategy. And so and positive physics doesn't force you to teach it like this, but it allows you to teach it this way if you want. So quick story is that circuits were always one of my favorite things to study when I was in school. And the first year that I taught them, we got so bogged down on teaching equivalent resistance, which is a very like abstract concept, that my students, even the ones that could figure out how to successfully like get the right answers, had very little conceptual understanding of electricity. And so I like to give students problems that have distinct routes. What I mean by that is there's not like can you guys see my mouse, by the way? Okay, cool. If you'd put a resistor right here, you couldn't use this method. But when each resistor is only on one route, so I highlighted this one route in blue that goes through resistors A and B, and then this other route only goes through resistor C. If the routes are distinct like that, then you can just apply Ohm's law to each route separately. So I highlighted this blue route. The 9-volt battery is powering current through A and B, which add up to 60 ohms. And so the current for A and B is going to be 9 over 60, or 0.15 amps. Then you could do 9 divided by 10 to figure out the current here. And that would give you 0.9 amps. And then to get the total current, you would just add 0.9 and 0.15, which I really like because it actually teaches the students that, okay, this current for A and B, a lot of times they'll think, oh, I'm just going to add up everything. But no, you only add up the current on the distinct routes, which I like that that's a very conceptual way to think about it too, because the same electrons that are going through B are going to later go through A. And so the disclaimer on this one is that if you teach it this way, I'd also be really sure to teach like the limits of this method and to teach students that if there had been a resistor right here that was on both routes, you'd have to use the equivalent resistance, which if you use positive physics, you'll see that in the challenge portions. Okay, those were my main 6 strategies. And my 7th one is to use positive physics. I'm very biased, but whether you use positive physics or not, I hope the previous 6 would help you. Positive physics builds in a lot of those strategies, or at least gives you the option to use them. Plus, it gives students questions with different numbers in them, which is really cool how it changed the conversations in my classroom to, hey, what's the answer to number 3, to how do you do number 3? Grades automatically, which also saves you a lot of time, so you can actually focus on your students instead of sitting at your desk grading. And yeah, it has the video lessons to reinforce your teaching as well. I know some people are new to positive physics and others aren't. So I wanted to pause to see if anybody had questions about this. And then if you got to go, perfectly fine. If not, I wanted to show people who are new to positive physics a little bit about the site, but obviously would love to take questions first, and feel free to hop off at any time. I know some of you are already experts on the site.
Hey, Jack, I'm curious, do you use this in the classroom or mostly just for homework, or both?
Yeah, so I used it for everything. And this is my 2nd year actually out of the classroom. But when I was teaching, I built it to do everything that I wanted to do in the classroom besides labs. And essentially how I would do it would be, I would just say this unit is going to be due. Usually a unit on positive physics goes for about a week and a half. And so I would just say, okay, everything, I would set all the due dates to next Wednesday or something like that. I would probably, start with an inquiry activity, then each lesson after that, probably spend the first half like going over the concepts, the second half letting students work on positive physics. So they'd use it in class, and then whatever they didn't get done became their homework. And then we'd do a lab towards the end of the unit, and then we'd use a positive physics assessment. Jim, did that answer your question?
Yeah, that answered it exactly.
Perfect. I saw a question in the chat from Paula. I can see that students would be tempted not to show work or to skip a lot of steps. How can you encourage them to show work? Yeah, so let me flip over to positive physics. So when I was teaching, I would give a grade for what they completed on positive physics. I think I gave 100 points just for their completion percentage, which ended up right here. And then I'd also give them a 50-point grade for showing their work. So we have a feature that goes in here. You go to print work problems. And then a lot of these, like, they're really quick. They don't really need to show their work. But for complete problems and review, and if you have them doing the challenge, I would print out a packet like this. And so it has them, since every student gets different numbers in their problems, once this preview comes up, you'll see there'll be a blank anywhere a student would insert their own numbers. And then I would require them to show their work. And I had a rubric that went with it, and I'd give them a 50-point grade for showing their work. Paula, let me know if that answers your question. Cool. Yeah, anything else, especially about the general strategies, and then I'm happy to show people who want to stick around anything about positive physics.
Can I just add, the person that asked the question about the work, I don't know if I should tell you this, Jack, but I give paper tests. I don't use the assessment function. I did during the year of COVID.
Gotcha.
But I steal your your printed stuff, and I give that as the printed test, right? And so the students learn really quick when they do a whole complete problem and they solved for one of the forces wrong and then got all the other things wrong because they showed me no work. You know, if they would have showed me that one piece that they got 18 instead of 19 or whatever. So they learn real quick that way when it comes down to their test grade. I can let whoever asked that know too. So I think having them, I don't love paper. I lose paper. I hate paper. And but I do the paper tests, and it's like the only piece of paper that I give, and it does hold them accountable. I had really big success this year, more than last year, like this past year, more than the year before, with kids actually keeping a notebook and taking notes during my slideshow. So I kind of begin every unit of yours with a slideshow that I've created, taking notes, and then doing the problems right in there. So now we're going to go to the, past the vocab and concepts once we've done that and stuff, into the complete problems and doing it right in that section. And I know some teachers even can give like a lab notebook grade. So you could do that. That's an idea too for someone. So.
Gotcha. And thank you, Amy. And I'm not offended at all. You use the site however you want to use it is the right way to use it. Cool. Any other questions? Maybe before I give a kind of intro to positive physics for those who haven't used it. Cool. All right. Yeah, actually, will you put in the chat if you have, just to make sure this is useful for some people, if you have not used positive physics at all, will you just kind of let me know in the chat? Oh, maybe everybody has. Cool. If yeah, and okay, Lori says gotcha. Okay, a couple people have. I know yeah, some people are experts, so if you hop off again, won't be offended at all. I'm going to go over from the very start, just kind of how to use positive physics. We have about 8 minutes until Zoom kicks us off, so I will be quick on that, and then always happy to hop back on if anybody needs more time. So cool. If you haven't used positive physics at all, I'm going to use for the I'm going to go over it from the very start. And yeah, it looks like we have a few. And yeah, thanks to the people who are hopping off. Thank you for stopping by. So yeah, if you haven't used positive physics at all, or even haven't created an account, I'll briefly go over some very quick things. So the first thing you do is create a teacher account. The only thing to be very mindful of is when you create a class code, this is the code you'll give to students to join your class. If you put your phone number there, I might give you a quick personal call, but I'll never share any of this information with anybody else. You won't get spammed. After that, then your students will join your class by clicking on I'm a student learner. And yes, my teacher uses this class. They'll enter your class code, and then they'll enter a username. By the way, we don't collect information. We collect as little information about students as possible. So for the username, please put something that lines up with your gradebook. So I usually tell my students to do last name and then first initial. And then you will select, they'll select the class period that they are in. All right. Once they register, they will end up on this screen. So this is the dashboard. You can set what unit that they'll show up on originally. So let's go ahead and take a look at that, like inclined forces unit, the one that I kind of talked about in the presentation. So again, it starts with just, or let me go back real quick. It starts with a review and then an inquiry activity. So sometimes for inquiry, we use PhET, and sometimes we just give students like data, and they start looking for patterns and kind of figuring out the equations they're going to use. And again, before we get to complete problems, we really break things down into bite-sized pieces. So first questions where they are just identifying the forces, the direction that forces would act on an object. If they get something wrong, so in this case, the normal force should be diagonally up to the right, then they can correct it. you'll notice in the top right-hand corner, if my face isn't in the way, that there's a completion score and an accuracy score. The completion score, if they get something right eventually, then their completion score will go up. Doesn't matter how many attempts it takes. The accuracy score just keeps track of if they get it right on the first try. I always grade on completion and then just tell students, look at your own accuracy score. That's what you need to study. All right, following that, we had some trigonometry and free body diagram analysis practice. So these again were the steps that I talked about at the start. I always need to point out, I think I mentioned this before, but every student gets different numbers in their problems. So again, it's really cool. They really curbs cheating and really just improves the conversations that your students are having with each other in the classroom. All right, so this takes them all the way down through challenge, and we even added some more AP style questions on so far they're in the first 5 units. So challenge are kind of AP level calculations, and multiple choice challenge are closer to AP style multiple choice questions. We did write these questions, so there's still randomization in here. Like if I get to one of these that's about graphs, different students will see a different looking graph, or they'll be asked about a different part of the graph. And so I think it's great to ask them for that on the homework. You can give them, we'll talk about the assessment a little bit more in just a second, but you can give them the same problem on the assessment, but it might be asking them about it. They might be getting a different graph or something on the assessment. So it seems very fair. They can't just memorize their answers, but you can tell them, no, you've seen this concept before. Again, feel free to interrupt or ask questions at any time. All right, and then we have a couple other modes. So we have the extra practice mode. What this does is if we go back and look at the work, so this complete problems 1 had 4 questions. The extra practice, and as a teacher, you can customize this. The extra practice it's going to randomly pull one of those 4 questions. And so a student can practice it. After the student finishes, they can click refresh and they can get another random question. So they have kind of unlimited practice here. And then finally on the assessment, by default, the assessment is locked. But before this, I did unlock an assessment in Unit 5. So what the assessment will do is it's going to randomly pull questions from their homework that they've already seen, but with different numbers. So it's going to randomly pull 2 embedded math questions, 2 free body diagram drawing questions, etc., all the way down to 1 problem from complete problems 4. When a student accesses the assessment, as they're working through, let me find one here. Okay, so as they're working through on this, they can check their answers at any time. They'll see their score going up, which they like. If they get it wrong, they won't be able to fix it right now. But once they finish and click finalize, they can come back and they can correct the answer right there. And you'll see that there's a separate correction score that'll pop up. And then as a teacher, I would give a separate correction score as well. On the teacher side, you can go and look at their scores. You can adjust settings and yeah, lots of all the things that you would expect for the teacher side. We're just over a minute left before Zoom unceremoniously kicks us out. I'm happy to hop back on after this if anybody has any questions. Just use the same link and you'll be able to and you'll join. But yeah, I think maybe the easiest thing is before I take questions, because it'll probably cut you off right in the middle of your question, I'm gonna go ahead and stop the meeting. If you want to hop on and ask any questions, I'd really would be more than happy to answer them. And besides that, thank you guys again for joining and really appreciate it. Also, my email address is on the homepage. Reach out every time. I always write back, usually a lot faster than you might expect. But thanks again, everyone. Really appreciate it. Hope you found it valuable. See ya.